Welcome to IOQM 2024 paper. Okay, this is part 3 of the video. Let's look at the 5 marks questions. In this video, we will cover 21 to 25. That is 5 questions we'll cover. Yeah, 21st question. An integer n is such that n by 9 floor value is 3-digit number with equal digits. Okay, n by 9 floor is 3-digit number with equal digits. And n minus 172 divided by 4 floor value is 4-digit number with the digits 2024 in same order, in some order. What is the remainder when n is divided by 100? Okay, which is trying to ask is basically last 2 digits of n. That is what is trying to ask us. Okay, so let's see. Okay, first thing is n minus 172 by 4 is a 4-digit number with digits from 2024. Okay, so either it should start with 2 or 4. Correct? It can't start with 0. And there are two 2's, so either the number should start with a 2 or 4. Let's take 4 first. Okay, if you take 4, this number, okay, n minus 172 by divided by 4 is between 4022, which is the smallest number which you can form with 4, and biggest number you can form is 4220, that is 4220. Okay, this implies if I separate this one, n by 4 and 43. Okay, 43 don't require a floor because it's already integer. N by 4 might require a floor, so I kept it separate like this. Okay, now if you simplify it further, 43 you take to the add 43 to the inequality, then it will become 4065 less than or equal to n by 4 less than or equal to 4263. Okay, which means again, okay, 4000, it will be either 4065 or 4264. Okay, it is possible that it can get some decimal value where by flooring it can go to uh, 4264. Okay, so this is the range basically, right? Okay, and now, so minimum value of n will be, if this is the case, correct, if you multiply with the 4, minimum value of n is 16,260. Okay, correct, this is 16,260, which means n by 9 will never get 3-digit number. It is always 4-digit. If you divide this number with 9, you will get only 4-digit number. Okay, so which means this number n does not or this expression does not start with 4. Okay, it, so only option is it has to start with 2 only. Correct, right? This expression is 1807, which is not divisible, so this cannot start with 4. This n by 4 minus 43 cannot start with 4, this expression. Okay, so possibility is 2024 less than or equal to n by 4 minus 43 less than or equal to 2420. Okay, so this is the equation we will look at now. Okay, now if I again simplify this expression, 43, add 43 to all, and then take n to the other side, what you will get is n is in between 8268 and 9856. Okay, n is from 8268 to 9856. Okay, now you know the range of n. Okay, now n by 9 is what? 3-digit number. So let's see what is the range of n by 9. Okay, so n by 9, if I divide this expression, I will get 918.6. Okay, less than or equal to n by 9 less than 1095.1. Okay, so this is anyway bigger, so maximum it can go is 999. Okay, correct. So if you see the n by 9 is 3-digit number with equal digits. Which number is possible in this range? In this range, only 999 is possible. N by 9 has to be 999, which means n by 9 is between 999 and 1000, right? Floor value. So n is between 8991 less than or equal to n less than 9000. Okay, so this is the range of n now, correct? If you take n equal to 8990, Okay, n minus 172 by 4, we get 2204, which is the exact definition of what n minus 172 to 172 by 4, right? With this floor function. So that means n has to be 8991. That's a possible value now, right? So if n equal to 8991, then remainder when n is divided by 100 is 91. This is the last two digits of n, which is 91. Okay. So this is more of number analysis and uh, that's it. It's just a number analysis, basically, number theory. Okay. So I would say this is medium for a 5 marks question, right? Let's do next. In a triangle ABC, angle BAC is 90. Okay, let's see if there is a diagram. Yes, yeah. ABC, there is a right angle triangle, and at A it is 90 degrees. And the DB point on BC, okay, BC, such that AB plus BD, okay, these two, sum of these two equal to AC plus CD. Okay. Suppose BD is to DC equal to 2 is to 1. So D is dividing BC in 2 is to 1 ratio. Okay. That means if this is X, this is 2X. This is X, this is 2X. Okay. Then asking us to find AC by AB in this format. Okay. Then what is the value of M plus N plus P? Okay. Let's come to this expression later. Okay, this is nothing but basically it's telling you write AC by AB in this format and then give me the value of M plus N plus P. Okay. Now let's look at this one carefully. Okay. He said AB plus BD equal to, okay. So if this is X, this is 2X, that we are clear now. Okay. And then if AB equal to Y, if AB equal to Y, then 2X plus Y equal to, it should be 2X plus Y. So AC has to be X plus Y. Okay. So this is our first derivation. AC has to be X plus Y. AC is X plus Y. Okay. Now I apply Pythagoras theorem on this. Okay. 3x square, that is 3x, right? 3x square equal to x plus y whole square plus y square. If I expand it, this is what I'll get. Okay. It is nothing but if I divide it with y square, or what I will get is 4x by y whole square minus x minus y minus 1 equal to 0. If k equal to, I assume that x by y as k, then it is a quadratic equation in k, right? And k roots are this one. Okay, 1 plus or minus square root of 1 plus 16 divided by 8. Okay, which means AC by AB equal to AC by AB. AC is x plus y, AB is y. So x plus y by y equal to, okay, if I divide it, x by y plus 1. Okay, and x by y is nothing but this value, correct? Right? Which is equal to k plus 1. So k is nothing but this value I am taking y. Why I am taking only this value? These are positive integers. Okay, right? These are positive integers I have to take. I can't take negative value here, minus. Okay, it is in m plus n plus square root of n by p form way, right? In this format. So I am taking 1 plus square root of 17 by 8 plus 1. If I simplified, what I will get is 9 plus square root of 17 by 8, which means m is 9, n is 17, p is 8. Correct? So m plus n plus p is 34. Okay, this is the answer. I think this is definitely easy for a 5 marks question. I think everybody should solve this. Okay, next. Yeah, next one. Consider 14 numbers 1 power 4, 2 power 4 up to 14 power 4. Okay, what is the smallest natural number n such that it leaves distinct reminders when divided by n? Okay, these numbers when divided by n, they should leave distinct reminders. All reminders should be different. Okay, what is such natural number and what is the smallest of that number? Okay, so this is definitely a counting problem. You can easily start checking from 15 onwards and go, but we can use some conditions so that we can actually restrict the counting. Okay, first thing is, we know from the remainder theorem, this can be written as, this problem can be written as x power 4 congruent to a modulo n, okay, which means x is any number from this series 1 to 14. Okay, x power 4, when I divide with n, it leaves the remainder a. Similarly, y power 4 congruent to b modulo n. Okay, it leaves another remainder b different from a. Okay, so here x comma y belongs to 1 to 14 and xy are distinct, and of course a comma b also distinct. Okay, now if you subtract these two from the remainder theorem, we know if you subtract these two, I will get x power 4 minus y power 4 congruent to a minus b modulo n, which means x by 4 minus y power 4 is not divisible by n. Okay, so I should find a n such that it won't divide x power 4 minus y power 4. Okay, so x power 4 minus y power 4 can be written as x minus y into x plus y into x square plus y square. Now we know that x minus 1 y range is 1 to 13, x plus y range is from uh, around 3 to 27. So all the numbers from 1 to 27, 1 to 27 will divide this numbers, right? 1 to 27 are done basically. They will all divide these numbers. You can form it with using this one easily. Now we should start counting from 28 onwards, and it should also not it should not be equal to x square plus y square, as well as it should not be formed from this expression. Okay, if it is formed from this expression, then or any multiple of it, then it is divisible. Correct. So 29 you can form 5 square plus 2 square. 30 we can say 2 into 3 into 5. It comes from which one? 2 and 1 if I take. Okay, 2 and 1 if I take. 2 plus 1 is 3. 2 plus 1 is 3. And 2 square plus 1 is 5. So 15 we can get into 2. Right? 2 from these numbers we can easily get. So 30 also is not possible. Also, if you look at 2 power 4 modulo 30, correct? 2 power 4 modulo 30 and 4 power 4 modulo 30, both are 16. So this is not a number what we are looking at. Next is 31. Yeah, this is a prime, and definitely it has to be a prime which can actually give 14 distinct numbers, a distinct remainder. It has to be a prime. Okay, prime is the highest possible possibility was there. So 31 is a prime, and it cannot be formed by x square plus 1. And okay, so which means 31 is the smallest number which leaves distinct remainders with 1 power 4 to when you uh, divide that these numbers with 31, then it leaves the distinct reminders. 31 is the answer. N is 31. Okay, it is, though it is a counting problem, it is truly it is a you should have a good mathematical brain to do this analysis actually. Otherwise you can blindly go from 15 onwards. You start counting 15 onwards, you start doing, actually you will hit at 31. You will hit, it's not a big deal. If you are really quick in math, I mean division, then you can do that way also. Okay, so this is definitely hard, time consuming at least, right? If you're doing counting also, it will be time consuming. Next, consider the set f of all polynomials whose coefficients are in the set of 0 comma 1. Means there is a set f which has all polynomials are in this. Okay, only thing is the polynomial coefficients are either 0 or 1. Means either the term is present or not present with a coefficient of 1. That's it. Okay, and qx is equal to x cube plus x plus 1. The number of polynomials p of x in f of degree 14. Okay, p of x is another polynomial which is part of f with a degree 14. Okay, such that product of p of x and q of x is also in f. Means first let's try to understand the problem. Okay, let's understand the question first. We have a function q of x equal to x cube plus x plus 1, and p of x is another function. Okay, it is of degree 14, which means you have a minimum term which is x power 14. That's it, dot. Okay, plus something else is there. Okay, now if I multiply, okay, if I multiply p of x and q of x, I should get a polynomial with coefficients only 1 and 0, 1 or 0. Okay, only then I will consider that as a p of x. And now the question is, how many such polynomials are possible? How many such p of x's are possible? Okay. Example, if I take p of x equal to, if I take x power 14 plus 1 plus x, p of x into q of x will become this. Okay. If I expand it, x power 17 plus x power 15 plus x power 14 plus x power 4 plus x power 2 plus x. Okay. This is definitely, each one has only quotient is only 1. Some are missing, which is 0. Right? So it belongs to f, which means this is a valid p of x. Okay? This is a valid definition of p of x. Okay? If I take another example, p of x is, let's say, x power 14 plus x power 13. Okay, if I multiply into with q of x, what happens? I get x power 17, x power uh, 16, x power 15, 2x power 14 plus x power 13. So here quotient is 2, which means this polynomial does not belong to f, which means p of x, this is not a definition of, this cannot be the definition of p of x. Okay. So now you know what is p of x, what is not p of x, and what should be our result. Okay. Now we understood the problem. Let's see how to do. We need to find the number of valid p of x. How many p of x are possible? That is the question. Okay. It looks very complicated, and it's a really, really good problem in this Olympiad. I haven't seen, I mean, up to 25, but up to 25, I would say this is the best problem. Okay. So you can do it in two ways. Okay. One is simple counting method. Okay. You can solve it. We will do that way. And also recursive method. If you are really advanced Olympiad practice you have done, you can use recursive method to solve this problem. Let's see how. Both methods will see. Okay. First thing, we know that q of x is this, p of x is this one. We need to find p of x. P of x is x power 14. This is one possibility. Simple. I don't want to add anything. Rest all are 0 coefficients. Correct? And x power 14, if I multiply with this number, definitely I will not get anywhere 2 coefficient. Correct? So this is one possibility. Count 1. Now, P of x can be in the form of two terms, basically x power 14 and another term is there. Okay? The second term is determined by power a. A can be 0 up to 0 to 13. Anything, right? Anything is possible. Correct? Okay, now let's see. X power a for p of x should be such that x power a into x cube plus x plus 1, this is q of x, okay, should not be any of x power 14 into, correct? First I will multiply this q of x with x power 14. I get some 3 terms, okay? X power a into q of x should not form any of these 3 terms, correct? If it forms, what happens? Quotient will become 2. So x power a into x cube plus x plus 1 should not generate x power 17, x power 15, x power 14, which means a should belong to, correct? A should belong to, a plus 3 should not be any of this, right? So a should belong to a plus 3 minus, right? This is a should be 10 onwards. If it is 11, what happens? 11 plus 3, if a is 11, 11 plus 3, it will become 14. 14 will come here, correct? So it cannot be any of this. A has to be 10 to 0. Okay, how many possibilities are here now? If I take only two term p of x, then 11 combinations are possible here. 11 possibilities here. So 11 plus 1, 12 you have. Now let's go to 3 terms. This we are doing a counting method, right? Simple counting method. We are trying to solve this problem. This is easy one. Most of you should choose this one to solve than recursiveness. That is for advanced Olympiad practitioners. Okay, let's see. Okay. Now, p of x can be x power 4 plus x power a plus x power b. Correct? 3 terms I am taking. Now, what should be a, what should be b? We already know a can be 10 onwards. Correct? X power a can be 10 onwards. So, x power b also has to be minus 4 from whatever a value. Correct? Only then you will not get a repetition. Otherwise, you will get repetition of terms. So, quotient will become 2 or more. Okay. So A can start from 10 and go down. B can start from A minus 4 and go down. Okay. Whatever is the value of A, B has to be A minus 4 is the maximum value. It can go down. Okay. So let's form a table for x power 14, P of x equal to x power 14 plus x power A plus x power B form. A can be 10, then B can be any of these values 6, 5, 4, 3, 2, 1, 0. 7 possibilities are there. Okay. If A equal to 10, B can be any of these 7. 7 possibilities are there. If A is 9, B will start from 5, because minus 4, right? 5, 4, 3, 2, 1, 0, 6 possibilities. Okay. Similarly, it will go down all the way. If A equal to 4, then there B cannot have any x term. Only it can have is constant term, that is 1. Okay. Not even 2. Okay. It can have only 1. Okay. So which is one possibility. So total possibilities here in this counting is 28. So far we have done 3 terms P of x we have calculated. Let's see if fourth one is possible. Okay. So fourth one, if P of x is in the form of x power 14 plus x power A plus x power B plus x power C form. Okay. Now for A equal to 1, B has to be 6, I am fixing. Okay. So C has to start from minus 4, right? So 2, 1, 0. 3 possibilities are there. If A is 10, B can take 5. B need not be always 6, right? B can go 5. Okay. In that case, I get only possibilities for C is 1 and 0. So 2 possibilities. Similarly, I am filling for complete this polynomial here. Okay. So A equal to 10, B can be 4, C is 0. X power 0 is the only possibility 1. Now I cannot go B more below this. B3 is not possible in this. Okay. If I go B3, then I can't get a C term. Okay. B3 is covered in this one already. In this one, B3 is covered already here, all these terms. Okay. So A equal to 9. If I take A equal to 9, B has to be maximum is 5. C is 1 and 0, 2 options are there. If A equal to 9, B can be 4. Then C is only one option. If A equal to 8, B is 4. C is only one option. So total possibilities here I have is 10 possibilities. Okay. Now I have got for polynomials of up to 4 terms I got. 1 term, 2 terms, 3 terms, 4 terms I got. Let's see if there is a fifth term possible. Okay. Is it possible? Really check it. 14, this will start at 10, minimum, maximum 10, this can be. This can be maximum 6. This can be maximum 2. So next one should be maximum minus 2. Minus 2, then it cannot be, you cannot call it as a polynomial, right? X power minus 2 is not a polynomial. So fifth 5-term polynomial is not possible. This is all the list what we have. Okay. So total how many? 1 plus 11 plus 28 plus 10, which is 50 possibilities of Px are there. Okay. Now this is the real good problem. Why I said is, see how much analysis you have to do. Even though once you understood the problem, the counting is so simple. You will definitely get correct answer once you figure out the counting method. Correct? Now, let's see same problem in recursive way for the advanced practitioners. I think if you really practice it well, uh, that is the most simplest. If you have practiced the recursive problems, then it's a very simple equation. Okay. Q of x equal to this one, we know P of x equal to x power 14 plus uh, something else, right? Now, Sn be the sum of all possibilities of P of x with degree n. Okay, with degree n. N here denotes not coefficient or terms, it denotes degree. Okay, which means S of 0 means it is 1, P of x is 1. S of 1 means P of x is x. Okay, so like that. Okay, x or x plus 1, both are possible. Okay, now let's see how to do this now. S of 0 is only one possibility. S of P of x is equal to 1, that's it. So one option. Okay, S of 1 is only 1 because P of x equal to x is possible. You multiply this with Q of x, you will get distinct, either 0 or 1 coefficients. Okay, but if you take x plus 1, okay, if you take x plus 1, it is not possible. Why? I get a x power 4 here, x square and x. Okay. With 1, I get one more x here. 1 into x, one more x I will get, right? So this is not possible term. So only one option. So S1 also only one. Sum of possibilities is only one. S2 is P of x equal to x square is possible. Okay. But x square plus x is not possible. X square plus 1 is not possible. X square plus x plus 1 also not possible. Okay. All the rest of the three are not possible. You can check multiplying with q of x. So s of 2 equal to 1. S of 3 similarly only one possibility. Only x cube is possible. Rest are not possible. We have seen in the previous example, once you choose, okay, once you choose one x power something, next three are not possible. Correct? So up to this, that's why you are getting only 1, 1, 1, 1. Okay. Let's see next. X power 4 is 2. So here there is a possibility because you can get x power 4 and x power 4 plus 1. Because next power is minus 4, right? X power 4 minus 4 is x power 0. So that is 1. This is a possibility, right? So S4 equal to 2. Okay. Other options are not possible. You can check. Okay. Just for your information, S5 equal to 3. X power 5 is possible. X power 5 plus x is possible because the difference of power is minus 4. If you see minimum. X power 5 plus 1 also possible. Okay. So these are the three possibilities. Now, looking at this, you can say that, okay, we can see a recursive trend here. What is the recursive trend here? Here it is sum of these two, basically, right? Here it is sum of definitely 2 plus, okay, S5 is equal to S4 plus, after that I cannot take next to 4 powers, right? So it will go S0, okay, 1. So this is the recursive equation. Okay, you can see a recursive trend from here. S of 3 equal to 1, S of 4 equal to 2. So S of n equal to Sn minus 1 plus Sn minus 4. Okay, so sum of these two. So from this, you need to just calculate from S4 onwards, then we'll get S5 equal to S4 plus 1. We have seen what is the value of S4, 2. And S1 is 1, so 2 plus 1, 3. S6 is 4, S7 is 5, S8 is S7 plus S4. Okay, S7 is 5, S4 is 2. Okay, from here 2 starts, so it is 7. S9 is 10, S10 is 14. Okay, similarly you go on S14. This is where what we are looking at. This is where we get minimum power of 14. Okay, P of x will have minimum degree 14. S13 plus S10. S13 is 36. S10 is 14. 36 plus 14, which is 50. So this is the recursive equation. If you are good in Olympiad practitioner, then you will definitely. It's a easy recursive equation. It is not a complicated recursive equation. Just two terms. Okay, recursion of two previous sums, right? So which is easy. It can go 3, 4 also sometimes. Okay, more complicated problems. So yeah, this is definitely tough, but it's a very, very interesting problem in this Olympiad. Okay, next. Yeah, definitely hard. I should put more hard, maybe. From here all, I should fill completely hard, 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 hard. Okay, next question, 25th. A finite set M of positive integers consists of M positive integers consists of perfect squares and a number 92. Okay, what is the set of M? Set of M has perfect square number, some n number of perfect squares and number 92. The average of numbers in M is 85. If you remove 92 from M, the average drops to 84. If n square is the largest possible square in M, what is the value of n? Okay, you should find the number n, which is the perfect square is the largest perfect square in set M. Okay, this looks easy at least. Okay, let's put it in the equation first. There are n number of perfect squares. Okay, that is ai square. I goes from 1 to n. Okay, ai square, sum of ai squares plus 92. average of this. That means there are n plus 1 terms. N perfect square 192 by divided by n plus 1 is 85. If 92 is removed from this, that is sigma I equal to 1 to n ai square. Okay. Only perfect square number, sum of perfect squares divided by n is equal to 84. Okay. Now from this we can easily derive n value. Correct. N is nothing but 85 into n plus 1 and minus 92, which is same, right, equal to 84n. Okay, that means n is equal to 7. So there are 7 number of perfect squares in set M. Okay, there are 7 perfect squares. Okay, so now sigma of 1 to 7 ai to the power of 2, this is, sorry, not I, ai square equal to 84 into 7, which average is 84. So n is 7. So if I take 7 other side, I'll get 588. So sum of 7 perfect squares is 588. Okay. So the biggest possible perfect square, okay, to get the biggest possible perfect square, other 6 should be distinct and least possible. Correct. If I want the biggest n, biggest of this perfect square number, other 6 should be smallest, right? So, and they are distinct. So I start from 1, 1 plus 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus n square. Okay, I don't know what is it, n is equal to 588. Okay, so n square is equal to, if I sum up all this, 91. So I'll get n square is 480. 497. Okay, this is my n square. Okay, now the question is, okay, how to get n value? N is, this is not a perfect square, so that means you should try to uh, change one of these numbers and get a perfect square for n. Okay, so nearest number is, if I see 497, nearest is 484, which is 22 square. Okay, so 1 square plus 2 square plus 3 square plus 4 square, I am just changing 6 to 7, 7 square. Okay, plus n square equal to 588. If I see here, this here, I get n square equal to 484. So n is equal to 22. This is the answer. I am sure looking at the other 5 marks questions, this is definitely easy. What do you say? Right? So easy to moderate, I would say, but yeah, easy, definitely. Okay. So these are the 5 questions we have done in this video. We'll come up with the last 5 questions in the next video. Just take your time and let the solution sink into your mind so that you can use these techniques to solve the other problems easily. Okay. Thank you.